Very much similar, very, very similar to what we just did with the augmented matrices and solving systems. But this time now we are going to use Gaussian elimination, kind of like we did before, but we're going to put it into what's called the triangular matrix, okay? To get into that triangular matrix, it's a specific thing called row echelon form. You'll notice here this one's not in row echelon form because this starts with a 0, 1, -3, and then it's a 1. So if you remember, this is really not in triangular form at all. Triangular form would mean that here in this first spot we'd have a 1, and then we'd have zeros underneath. And then you might have a 1 here with zeros underneath, and then a 1 here with a 0, and then a 1 here. And zeros would be all, so that'd be kind of more like triangular form. Now sometimes you might have like a 1 with, 1 with whatever, and then you might have like 2 zeros and a 1, and then 3 zeros and a 1, and then no zeros type thing. And you'll see that here on slide 25. So as we look at slide 25, this is what's known as row echelon form. We kind of think of it maybe more like, again, like triangular form. So again, look at it. You have 1 with zeros. There is no 0, there is no 1 here, but these are all zeros, and then 1 here with the zeros, 1 here with the 0. This is row echelon form. Now, when it gets to what's called reduced row echelon form is where you'd actually take your row echelon form, back substitute it up. So you would basically, instead of working your way down, you'd work your way back up, eliminating the number that's above the 1. Then you'll get zeros below and zeros above. And when that happens, it's in what's called reduced row echelon form. If it's in reduced row echelon form, then solving is very, very simple. Like here we would say that z, or whatever, actually this would be x, y, this would be probably w, x, y, and z. So z equals a half. We'd say then y equals -3. And then we could use that information to help us solve and find the rest. So here we go. We're going to do Gaussian elimination. We're going to first put into what's called row echelon form, okay? And it's called Gaussian elimination. Solve the system of linear equations using Gaussian elimination, which means they want you to put it into row echelon form, which means we want that triangular type of matrix. So if you look at it, let's first put it into an augmented matrix right here. And put it into an augmented matrix right here. So we have 4, we have 8, we have -4, and we have 4. So remember, this is going to represent all our x's, all our y's, and all our z's. So then we have 3, -2, 8, 1, 5, 12. And then here's our solutions, and we have -11 and 17. -17. That'd be important. -17. So the very first thing I'm going to do is I'm going to say, you know what? If I divide this whole top row by 4, so in other words, remember this is row 1, row 2, row 3. So if I were to take 1/4 of row 1 and replace it with row 1, I would get, well, 1/4 of 4 is 1. 1/4 of 8 is 2. 1/4 of -4 is -1. 1/4 of 4 is 1. Now get that. I now have 3, 8, 5, -11, -2, 1, 12, -17. I want to now get this to be a 0. Okay, I want to get this to be a 0. So I'm going to multiply the top. So I'm going to take -3 times row 1 and add it to row 2 and replace that with row 2, because that'll get rid of that 3 right there. So if I do that, I get -3 times 1. -3 times 1 is -3. So okay, remember, the top matrix isn't going to change. It's still 1, 2, -1, 1. Now if I take negative 3 times 1 is negative 3 plus 3, that's 0. That's what I want. Negative 3 times 2 is negative 6 plus 8 is 2. Negative 3 times negative 1 is 3 plus 5 is 8. Negative 3 times 1 is negative 3 minus 11 is negative 14. I then have negative 2, 1. And you know what? Maybe to speed up the process a little bit here, not totally speed it up, but you know what? We know we want this to be a 0 as well. So now what I'm going to do is I'm going to take 2 times row 1 and add it to row 3, and that's going to become my new row 3. That'll give me a 0 here. Because see how this is negative 2? So now if I take 2 times row 1, 2 times 1 is 2. 2 plus negative 2 is 0. 2 times 2 is 4, plus 1 is 5. 2 times negative 1 is negative 2, plus 12 is 10. 2 times 1 is 2, plus negative 17 is negative 15. So I just kind of did 2 at the same time, not really at the exact same time, right? You saw me do this one, and then I said, well, I know I want that to be 0, so I'm going to do that. Now I want to get this to be a 1. I want this to be a 1 right here. So I would take 1/2, scoot up just a little bit. I'm going to take 1/2 times row 2, and I'm going to replace that with row 2. So I get, this one stays the same, 1, 2, negative 1, 1. This becomes 0, 1, 4, negative 7, because I'm just taking half of all these numbers, 0, 5, 10, negative 15. Now I want to get this to be a 0. I want this to be 0 right here. So if I took negative 5 times row 2, add it to row 3, and that becomes my new row 3, I would get, so negative 5 times row 2, negative 5 times 0 is 0 plus 0 is 0. So again, the top one's not changing. It stayed the same. I might open this up a little bit so I'm not squished. Negative 5 times 0, okay, oh, the second one doesn't change either, by the way. We're not doing anything in the second one. See, we're replacing it to row 3. So negative 5 times 0 is 0 plus 0 is 0, that goes there. Negative 5 times 1 is negative 5 plus 5 is 0, that goes there. Negative 5 times 4 is negative 20, plus 10 is negative 10. Negative 5 times negative 7 is 35. 35 minus 15 is 20. So there you go. Now we just need to get this to be a 1 right here, which is a fairly simple deal. What are we going to do? That's right, we're just going to take 1/10 of row 3 and replace it with row 3. So row 1 and row 2, again, I don't know why I love to make that so small. Just make it kind of big. It's nothing. Don't be afraid to use paper here, folks. You're going to need to use lots of paper. 1, 2, negative 1, 1, 0, 1, 4, negative 7, 0, 0. Actually, and I need it to be a negative 1/10, because that's a negative right there, so that's going to become a 1. Negative 1/10 times 20 be negative 2. So now I know what z is. So I know z equals negative 2. By back substituting, I can come back to here, or actually just right into here, and say, well, 1y plus 4 of these z's, so that's going to be 4 times negative 2. It's got to give me negative 7. 4 times negative 2 is negative 8. So if I add over 8, I would get y equals 1. So now that I know z is negative 2, I know y is 1, I can now find x because it says 1x plus 2y's, which is 1, minus 1z, which is a negative 2. It's got to equal 1, so that's going to be a plus there. So that's going to be x plus 2 is 4 equals 1. X got to equal negative 3. So there's my solution. My solution is negative 3, 1, negative 2. And there you go. Woohoo! Lots of fun, I know. Okay, so that's called Gaussian elimination. by using, and we put into what's called row echelon form. Okay? Now, here's the deal. Here's the deal. I'm going to keep going here. There's this thing called Gauss-Jordan elimination. So Gaussian elimination with Jordan. So there's, it just is a little bit more. So it's now, remember how I showed you the difference between row echelon form and reduced row echelon form? Gaussian Jordan elimination puts it into reduced row echelon form, which means we want zeros on top and bottom of the ones. Okay? Which basically just means we're solving for what x and y are. So, here's the deal. Here's the deal. The first thing you're going to do in Gauss-Jordan elimination is you're going to first put it very first put it into augmented matrix. Then you're going to get into row echelon form. The one with zeros, one with the 0, 1. These are numbers. Then what you're going to do is you're going to work backwards, back substituting, and you're going to like multiply this one by something and add it to this to eliminate it so that it becomes a 0. So then you end up with something like this, where you have 0, 0, 1, a number, 0, 1, 0, a number, because now you know that this z equals this y equals that. And then to get rid of this, you're going to multiply this one here by something and add it to here to get it to be 0. And then it goes. So this is called Gauss-Jordan elimination. I'm going to show you in the next example. Here we go. Ready? Hold on tight. Don't be afraid to use lots of paper. Here we go. Here we go. So very first step, get it in an augmented matrix. That's step number 1. So I have 4, 3, negative 2, and again, that's all my x's. All my y's are 8, 8, 1. All my z's are going to be negative 4, 5, 12. And then all the solutions are 4. Sorry, I'm a little tight here. Negative 11, negative 17. Okay? Very first thing we want to do is we want to get it into row echelon form. So again, take 1/4 of row 1. Remember, this is row 1, row 2, and row 3. I would take 1/4 of row 1 and replace it with row 1. So that gives me 1, 2, negative 1, 1. So I'm just taking 1/4 of each of these. Okay? Then I have the 3, the 8, the 5, negative 11, negative 2, 1, 12, negative 17. So I know I want to eliminate both of these and make them zeros. So the first thing I'm going to do is I'm going to take negative 3 times row 1, add it to row 2, and replace that with row 2. Then I'm going to take, and this is a negative 2, so I'm going to take 2 times row 1, add it to row 3, and replace with row 3. So I can do these two kind of in a sense simultaneously. They don't really per se happen simultaneously, but they can happen in the same step. So negative 3 times 1, so the first row is not changing. Not doing anything to it. See, the resulting is going into row 2 and into row 3, so row 1 stays the same. So I take negative 3 times 1, negative 3 plus 3 is 0. Negative 3 times 2 is negative 6, plus 8 is 2. Negative 3 times negative 1 is 3, plus 5 is 8. Negative 3 times 1 is negative 3, plus negative 11, negative 14. I take 2 times 1 is 2, plus negative 2, that's the bottom one there, that's 0. 2 times 2 is 4, plus 1 is 5, goes right there. 2 times negative 1 is negative 2, plus 12 is 10. Right there, and 2 times 1 is 2 plus negative 17 is negative 15. Okay? Now I'm going to divide each of these by 2 right here. And I might, looking at this, I might divide each of these by 5. So I might take 1/2 of row 2, and that's going to become row 2, and I might take 1/5 of row 5, and that's going to become row, and that's 1/5 of row 3 is going to become row 3. Sorry, 1/5 of 5. Yeah, that was funny. Okay, let's look at it here. So the top row, again, nothing's happening to it. It's staying the same. 1/2 of this is going to be 0, 1, 4, -7. 1/5 of this is going to be 0, 1, 2, -3. It just brings these numbers down a little bit easier to work with because they were all divisible by 5. Okay? Now I want to eliminate this one right here, and I'll have it in row, well, almost row echelon form, right? So I'm just going to subtract the 2. So if I just take row 2 minus row 3, and that becomes my new row 3, it'll be in almost row echelon form. So close. 1, 2, -1, 1. Row 2 doesn't change. 0, 1, 4, -7. 0 minus 0 is 0. 1 minus 1 is 0. 4 minus 2 is 2. -7 minus a -3 is a -4, because -7 minus -3 would be -7 plus 3. Now divide by 2. So if I take 1/2 of R3 and it becomes R3, I now have it in row echelon form. So 1, nothing happens to it. 2, nothing happens to it. And 3, I get 0, 0, 1, -2. So I now know that z equals -2. Okay? But I don't want to just solve it by Gaussian elimination. I want to solve it by Gauss-Jordan elimination, which means I want to get into reduced row echelon form. Reduced row echelon form. So I want to get this now to become a 0 right here. So if I were to take -4 times row 3, add it to row 2, and that becomes my new row 2, watch what happens, okay? So the top row stays the same, and the bottom row stays the same. They don't change. The middle row now is going to be changed, though. I'm going to take -4 times row 3. So that's going to be 0. Then I'm going to add it to row 2. Plus 0 is 0. -4 times 0 plus 1 is 1. -4 times 1 is -4 plus 4 is 0. -4 times -2 is 8 plus -7 is 1. So that means that 1y equals 1 equals 1. So therefore y equals 1. Now, I'm going to do the same thing to row 1. So in other words, I'm going to multiply. Actually, I just have to add. If I just add row 3 to row 1, if I add just row 3 to row 1 and replace that with row 1, look what I get. I'm off the paper yet, okay. So I get 0 plus 1 is 1, 0 plus 2 is 2, 1 plus -1 is 0, -2 plus 1 is -1, 0, 1, 0, 1, 0, 0, 1, -2. Now I need to eliminate this guy right here, and I'll have it in row reduced echelon form. A reduced row, I keep saying that, reduced row echelon form. So fun. Tongue twister right there, folks. So if I were to take -2 times row 2, so I'm going to come over here now. If I take -2 times row 2, add it to row 1, and replace that with row 1, I will have it. So row 3, nothing's changing. 0, 0, 1, -2. Row 2, nothing's changing. 0, 1, 0, 1. Now, row 1 is changing. -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2. -2 plus 2 is 0. -2 times 0 is 0, plus 0 is 0. -2 times 1 is -2, plus -1 is -3, and there we have that 1x is -3. So in other words, x equals -3. So there's our solution, -3, 1, -2. If you remember right back here, that's exactly what we got. They were exactly the same matrices. I don't know if you guys noticed that, but they were the exact same system. We got the exact same answer right here. -3, 1, -2. -3, 1, -2. This is just doing it all in matrices instead of using matrices to find z and then back substituting it all. Okay? All right, that is called Jordan Gaussian elimination or reduced row echelon form. And folks, I'll see you in the next video. We got one more video for this section. Going to talk about inconsistent and consistent or dependent, independent. Here we go. Coming at you.